Hello everyone, our project name is Cartoon Face. Now let me introduce something about our project. It's a very exciting idea. We expected to make this program producing people's cartoon face based on their real face photos. It involves different fields in machine learning like face detection, face extraction, classification, best fitting, and so on. We expected the difficulties will be in the feature extraction part and also in the choose best fitting features part. And finally, we want to make this program really cool and can be used in the future. Now, the second part is the preliminaries of our program. As you can see, I put 4 pictures here, 4 screenshots, which is all our group members. The left picture is a real picture we take by ourselves, for example, and the right cartoon face pictures is constructed by our program. Really cool, huh? I guess you guys might be very curious about how we implement this. So let me introduce that one by one for you. The first step is that we need to make the face detection here. In this case, we just use Lena's classic picture. As you can see, we can already use a green box, which here bounding the Lena's face. After that, the second step is we need to implement the face feature decompose. In this part, because our cartoon face are based on combination of different cartoon features together, very interesting things. So we need to again use the detection method to using this small box to bounding Lena's eyes, nose, and mouth here. Okay. After we implement that, we get into the third step, which is feature extraction. Here, we try many methods and spend many times in this part. It's a very important part for our project. As you know, good features will give a dramatic impact to our later classification. And last, we decided to assign different weight to 3 kinds of features: row pixel, gradient, and histogram of oriented gradients. For example, we assign like 0.3 to the row pixel, 0.7 to the gradient, and 1 for the final hog method. As you can see, this is a histogram of our row pixel. And this is a gradient pictures, and this is gradient direction, which we divided that into 32 direction vectors here. And finally, this picture is hog, which drawn by the hog method. Okay, now after we successfully implement that, now we can make our classification. So here, our group finally decided to use the k-means method. So why do we choose that? Of course, k-means method runs faster than SVM, as you know, and because we have many pictures, which includes many pixels here, we need to process many data. So we just choose the efficiency method to help us make the classification. And then after that, the fifth step is to mapping the cartoon features. And finally, we just combination the cartoon features in our GUI. So this picture is our GUI interface.
Well, for the next part, we will say during the project, we have some successful point. Firstly, we successfully implement the k-means classification algorithm. Next, for the extract the feature, we have used 3 methods like row pixel, image gradient, and the hog method to extract the feature. And we want to try to combine this with a good way to show a good classification, and we also fix some grammar errors. Well, some failure point also makes us feel a little disappointed. Well, first failure point is the MATLAB instruction of vector calculation, and next is about the first centralized choice, because the first centralized choice is greatly influenced the classification. Well, sometimes the misclassifications run badly, especially when the face picture take from different angles, and also we don't have many pictures for one person's face, so error rate is sometimes a little high when making training data. Well, next is for the conclusion and the future works.
As for the conclusion and future work, we really enjoy the process of this project, and we get familiar with MATLAB through this process. And the program is really funny, which can help us draw our cartoon face automatically. Also, the technique used in this project can also be used in other ideas. For example, we can also differentiate one specific person from a group photo by using other features extraction methods and classification methods. When talking about a future work, we want to do this project could be used in some real program someday. Of course, the accuracy of feature extraction still need to be improved. Next part is our demo of this project.
Okay, now I will show you the demo presentation here. And we just open the MATLAB and click the run button to run the training process. And the training process is like this: to use the feature extraction function, and we get the histogram of the image gradient, and the whole feature. And we use these features to do the classification, more exactly to use k-means to do the classification and make it cluster into 4 clusters here, which means 4 group here. We use the picture here, and now it is running, so we just wait for the result. It takes a little slow. And now it runs the k-means process. Yeah, it comes out. So the one as a column means the index of the photo, and the 1, 2, 3, 4 here means the cluster it belongs to. So we can see photo 5, 6, 7, 8, 9, 10 share the same number 3, which means they are in the same group. So let's check. 3, 5, 6, 7, 8, 9, 10. Yeah, they're exactly the same person, so they share the same cluster. That makes sense. This is our result of the clustering. Now let's show the cartoon face transformation part. So here we just click the match function here, and we use the image that we used to test. Here we go, and just click the enter. Yeah, it shows the result. This is the cartoon image of one of our group member. I've done 4 images for our group members. I can show you here. This is our group member Minshu Xian, and this is the cartoon face for Mingzi, and this is the cartoon face for Jun Chen, and this is the cartoon face for Yifan Guo. This is what we done at this machine learning class, and thank you for listening.